So today we are going to move on to the next unit in geometry, which is very short. It's just 2 lessons, but it's on logic. Logic is very different than what we have done in the past with algebra. There's no solving equations. It's just different types of reasoning. And today we're going to learn about inductive reasoning. So if you use a pattern and you guess what comes next, that's called inductive reasoning. We're going to learn something that's called a conjecture. And that's an unproven statement. It is not proven. It's just based on an observation. So if I walked into my classroom and I said, everyone in here is 15. It's an unproven statement. It's based on an observation that I noticed in my classroom, but it doesn't necessarily mean it's true. It's just a conjecture. Inductive reasoning is writing a conjecture based off of an observation of patterns. And then a counterexample is a specific case that shows that the conjecture is false. So someone might raise their hand and say, well, I'm not 15, I'm 14, or I'm 16. And that would be called a counterexample. My dog is whining. Hold on just a second. All right, see if you can create that fourth pattern. I open and close the door for my dog. Okay. Oh, I already have it on the screen here. That's fine. All right, so you look at the first 3 figures and you create the fourth one based on what you see. Let's see if you can do the same thing for example 2. So take a look at the 4 numbers, and you've done this before, where you look at them and you say, hey, aren't you just multiplying by 4 there? You just break out your calculator, negative 64 times 4, and times 4, and times 4 again, and you get the next 3 numbers in the pattern. So there you go. So we are going to make a conjecture. And there are many different ways, but this is just one example. Okay, so make a table and look for a pattern. So you notice the pattern is how the number of connections increases. Okay, I'm reading this, but I'm sure you haven't seen the table yet. So if you have a picture where you have just 1 point, okay, you're not going to have any connections to any other points. So that's 0. Why isn't my pen drying? White. Okay. So if you have 2 points, you're going to make 1 connection in between those 2 points. Now, once you have 3 points, you'll have 1, 2, 3 connections. I'm just counting them. If you have 4 connections, you'll have 4 dots, you have 6 connections. So you can count the ones for 5, or you can keep counting and going up, or you can look for a pattern. So between 0 and 1, we're adding 1. Between 1 and 3, we're adding 2. Between 3 and 6, we're adding 4. So, oops. 3 and 6, we're adding 3. You guys are probably like, what the what? That's why, like, when we're in class, someone will raise their hand and be like, Miss Helbing. So 6 plus 4 is probably going to give us 10. And we can go ahead and count, but that's our conjecture. So you can connect 5 non-collinear points, even though we didn't count them. We're just making a conjecture. We're guessing 10 different ways. Okay, so we are going to take numbers such as 1, 3, and 5, and they're called consecutive odd numbers. Consecutive means right after each other. Odd, 1, 3, 5, 7, 9. Consecutive odd numbers. Make and test a conjecture about the sum of any 3 consecutive odd numbers. So you would just pick. And if we were in class, everyone would pick 3 different numbers, and we'd all share our answers, and someone would say, hey, all those answers are odd. Yes, they are. The sum of any 3 consecutive odd numbers is odd. Now, that is just the easiest way to finish that and to write a conjecture, but there are different answers. Some people have come up with, well, there isn't the number divisible by 3. Yes, it is. So that's not the only conjecture you can come up with. Okay, we're going to move on to conditional statements. Conditional statement is a logical statement that has 2 parts: the beginning, the hypothesis, and then the conclusion, the end. And if we write it in what's called if-then form, we put the if before the hypothesis and then before the conclusion. So in my example of this conditional statement, when it rains, there are clouds in the sky. If I wanted to put that in if-then form, I would write if it rains, then there are clouds in the sky. It is so hard to write on my screen here. Okay. That's it there. So we're going to rewrite the conditional statement into if-then form. So go ahead and try that. Press pause. And after you've finished, come back and let's see if you have the right answers. So, and you might have used a different word, but I used the word it. So if it is a vertebrate, you could add the word animal, okay, or whatever. Then it has a backbone. And again, I apologize for my handwriting. It's very hard to write on the screen. For all triangles have three sides. If it is a triangle, then it has three sides. If hypothesis, then conclusion. Just trying to make sure I didn't skip anything. Okay, so in a negation, you probably could guess what that is. It's the opposite of the original statement. So if the statement is the ball is bouncy, the negation would be the ball is not bouncy. You wouldn't say the ball is flat or use another word. You have to use the opposite. You have to use not bouncy. So for example, in statement 2, the cat is not black. You would say the cat is black. You wouldn't say the cat is blue. Okay. So conditional statements, they can be true or they can be false. In order for them to be true, they have to be true for every single conclusion, every single example you can possibly come up with. They are false if you can come up with one counterexample. So if you remember the statement that I made earlier, I made the conjecture, everyone here is 15. If we can find one person in the class that is not 15, and we have a counterexample, then the entire statement is false. It doesn't matter how many people are 15. We could find one that's not. So we are going to now move on to related conditionals. So we just talked about and I think I skipped a couple examples that we would do in class. And they're more for discussion, which I can't do on here. So we're going to write these out. So here's our statement. Olympians are athletes. So let's see if we can write that in if-then form. If you are an Olympian, then you are an athlete. Okay, so we would have a discussion about that and we'd say, yeah, it's probably true. Okay, the converse is when you exchange the hypothesis and the conclusion, and you need to know that. Okay, so we're just going to flip the hypothesis and the conclusion. So if you are an athlete, then you are an Olympian. Oh gosh, I can't write. And we would have a discussion about that, and someone would say, just because you're an athlete doesn't mean you're an Olympian, so that would definitely be false. The converse would be false. The inverse is when you negate the hypothesis, you make it negative, and the conclusion, make it negative from the original statement. So this original if-then, we're just going to write the same thing, but we're going to make them not. So if you are not, oh gosh, an Olympian, then you are not, this is barely legible, an athlete. I missed my Promethean board. Okay, and then we'd have discussion about that, and we'd say, well, just because you're not an Olympian, it doesn't mean that you're not an athlete. So that's false. And the contrapositive is when you write the converse and then you negate the hypothesis and the conclusion. So you flip it and you make it negative. So if you're not an athlete, then you are not an Olympian. Think about that for a second. And we'd say, well, I mean, if you're not an athlete, you're not Olympian. That's true. Probably. We'd have a discussion about it. But if you notice, the if-then, the original if-then and the contrapositive have the same truth value, as well as the converse and the inverse have the same truth values. And we're going to get to that in just a second. So see if you can try the example about the Great Dane and press pause right now, and then come back and I'll show you the answers. All right, so if a dog is a Great Dane, then it's large. There's your statement. The converse is if a dog is large, then it's a Great Dane. The inverse is if a dog is not a Great Dane, then it's not large. And the contrapositive is if a dog isn't large or is not large, then it's not a Great Dane. Look at the truth statements here. Those are notice the converse and the inverse are the same. They're both false, and then the original statement and the last one is the same as well. And with that, those are called equivalent statements. The statement, the original if-then, and its contrapositive are going to have the same truth value. So if one's false, the other one's false. And same for the inverse and the converse. If one's true, the other one's true. Or false, then they're false. Okay, biconditional. This is what some people have trouble with sometimes. So sometimes you have a statement, a conditional statement, and both the original statement and its converse, when you flip the hypothesis and the conclusion, it's also true. So when that happens, instead of writing both the if-then and the converse, we can write them together in a biconditional. So if, and here's your hypothesis, if two lines form a right triangle, then they are perpendicular. Here's your conclusion. So here's the converse. If two lines are perpendicular, so there's your original conclusion, right? Then they form a right triangle. There's your hypothesis. So notice they're flipped. That's the converse. Well, both of those statements are true. So what we can do is we can write the hypothesis and then if and only if, and that's a shortcut, how to write if and only if, conclusion. Or you can write the conclusion if and only if the hypothesis. But if you write the if and only if, that tells you it doesn't matter which one you put first, hypothesis or the conclusion. Either way, it's going to be true statement. So I think we have an example I'd like for you to try on the next page. Okay, so if two lines are parallel, I started it for you. Then, I think I have this done, do I? Yes. They lie on the same plane and they do not intersect. That's the converse. Let me move this so you can see what I wrote, and that's not possible. It's fine. Everything's fine. Okay, so let's see if you can write the biconditional. So if, and it doesn't matter if you write the hypothesis or the conclusion first. There's one of them, and then there's the other one. Okay, whether one is the hypothesis, one is the conclusion, you can write whichever one you want, and then if and only if, and then the other one. But no if and no then. Try it, press pause, and we'll come back. I have 1 minute left. So two lines are parallel if and only if they lie in the same plane and do not intersect. So the last thing we need to go over is just a couple things about perpendicular lines. So the symbol for perpendicular is this upside down T. Okay, so in order for us to know that lines are perpendicular, they either have to, we either got to have this right angle there that tells us the two lines are perpendicular, or we can have this symbol. Now these lines could be, those lines are definitely not perpendicular. However, these could be, they look like they might be, but we can't guarantee that they are perpendicular because we would need one of these, we need to be told. Okay, I think that's it. We're out. Peace out.